Algebraic patterns, example 1, linear and quadratic expressions. Here we've been asked to examine the patterns, determine if they're quadratic or linear relationships, and write the algebraic expression. Let's look at the first one, A. The terms given are -2, 1, 4, and 7. So the first term is -2 and the second term 3. So I'm writing out what they are. Let's look at the first difference. The difference going from -2 to 1 is adding 3, and we add 3 to the next term and add 3 to the next term. So to get to each next term, you would add 3 each time. So the first difference is +3. If the first difference is constant, we know that the relationship is a linear relationship. Linear relationships have the shape that term n would be equal to an plus b, just like y equals mx plus c. This an plus b is the shape of a linear relationship. So we want to find out the value of a and the value of b. A is the first difference in a linear relationship. So straight away we can write a equals 3. B would be the zero term if it existed. It doesn't exist, but if we could count backwards, take 3 from -2, we would see that -5 would be the zero term if it existed. So we can say that b is equal to -5. So an plus b would then be written as 3n minus 5. So this expression is 3n minus 5. Now let's look at part B. Again, let's look at what terms do we have here. So we have 3, 5, 11, 21. Again, we work out the first difference for this. So just stating which term each is. The first difference, the difference in 3 and 5 is 2. Between 5 and 11 is 6. And 11 and 21 is 10. The first difference is not constant, so this is not linear. Let's look at the second difference. From 2 to 6 we add 4, and 6 to 10 we add 4. The second difference is constant, so we can say this is a quadratic expression if the second difference is constant. So we know the shape of this expression as well. Quadratic expressions have the shape an squared plus bn plus c. So now what we need to do is work out these values, the parameters a, b, and c. We know that a is equal to 1/2 the second difference in a quadratic expression. So 1/2 of 4 would be 2. So the value of a is going to be 2 in this example. Next, we could work out the c value. This would be the value of the zero term. Counting backwards, we could work this out. So what would we have added 4 to get +2? And then what would we add -2 to get 3? We could work out that the zero term, even though it doesn't exist, if it did exist, it would be 5. The value of the expression when n would be equal to 0 is 5. Now we only have to work out what b is. We know most of what the expression is already. So we know that a is 2, so we have 2n squared. It's bn, and we know that c is +5. So this is an equation for each term. And we have some inputs and outputs. We know, for instance, term 1, its value is 3. So if we substitute 1 in for n into this expression, we get the output 3. So we can say 2 times 1 squared plus b times 1 plus 5 is equal to 3. And just quickly working this out, we can see that b is equal to -4. So we've answered the question at this stage. We know what a, b, and c are. So we can give an algebraic expression for this quadratic. So a is 2, so we have 2n squared. B is -4, so it's -4n. And c is +5.